Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day to each and everyone. So Alhamdulillah, no, so for last meeting, we have already discussed the first topics no supposedly to be discussed on our first prelim. But since no, and once again as I have said, we have actually a busy time no for to completely discuss all the topics that we have to discuss. But since no, syempre no, maliit lang naman yung topics natin for this subject. Okay? So just a little no, consideration. Okay? So yun. So continue natin yung discussion natin. So we have here lesson 2, no? We have here the state space and transfer matrix models of linear time invariant differential system. Now, so from our last meeting, okay, from our last meeting, where we talked about the advantage and disadvantage, or what, or probably no specifically the advantage of the feedback system. Okay, but no, since we have noticed there that um, we can actually apply the concept of feedback system if and only if the depth or the systems that we are using is in based on um, time invariant, no? So ibig sabihin nun, we can really vary the configuration or the flow of the signals, okay, throughout the path that we have to consider by variation of differential system, okay? So yun. Um, we have here state space transfer matrix model of linear time invariant system. Okay, so we have here signal and system. Okay, so no, just giving you a small or brief overview about signals. Now, when you say signals, those those continuity of value of function, no, in relation to its domain, or ibig sabihin nun, at some time, no, kung yung signal mo is a function of time, at some value of time, it has a certain corresponding value of its degrees, no, or its value, okay, um at a certain time. So take note here that continuous, no, yun yung tinatawag nating signal. So may mga signals din naman that is not continuous. Ibig sabihin may discontinuity yun siya. Tinatawag pa rin natin yung siyang signal. It's because it is defined, no, yung value niya is also defined with respect to time. Okay? So for example, this speed of car, no, v of t, no, velocity with respect to time, no. So as you can see here, as the time goes by, the value of v of t is changing continuously. Okay? By basing on this graph here. Okay, so now yun, as I have said, signal have uh two classification. We have continuous time signal, so ito yung example natin dito sa example number 1. Tapos discrete time signal is those signals that is not continuous, no. Ibig sabihin we cannot draw, or we cannot relate the previous value of signal into um, upcoming values of signals kasi discrete nga eh. Okay, so the function are discrete variables. They are defined only by for integer value of independent variables. Okay, so time steps, no? Yung kuan nila, yung configuration niya. For example, this one, no? As you can see here, this is not a continuous signals, but instead a discrete one. Okay, so as time or as month goes by, it has a, a value that is only defined for that time only, for that situation only. For example, no, for example, for this graph here, for the first month, the value of the stock value in dollars is only about this, okay, about this graph, no, for that certain value lang. Okay, for example naman, this dito, no, for some value of n month dito, meron siyang value na about dito. Okay, so yun, so dyan lang kumbaga define yung kanilang value for at a certain time. Okay, so ibig sabihin hindi siya continuous. Okay, so yun. Now, dito tayo sa signal time shift. For the signal time shift naman, ito yung mga signals okay, in which the signals is being shifted at some certain time. Okay, so ibig sabihin nun, yung kumbaga yung value ng function natin or yung value ng function natin at a certain time is na-shift siya into some value of time. So, ibig sabihin nun, from that value na mayroon siya dapat, from that time na mayroon siyang certain value dapat, nangyari siya into more recently time, kumbaga, no? So, ibig sabihin nun, for example, this one here, the value here, okay? So, supposedly mangyayari yan siya from 0 to 2. So, kung isi-shift natin yun siya into 2 seconds, so yun. Ibig sabihin nun, instead na dito mangyayari yung x of t mo, dito na lang siya mangyari sa from -2 to 0. Okay? So, ibig sabihin na shift siya into 2 seconds. Okay? So, yun. Now, dito tayo sa periodic signal. What do you mean by periodic signal? Periodic signal is those signals in which, okay, the value of the signal is happened, okay, or the value of signals is being repeated, okay, for some value of time. Okay, so ibig sabihin nun, for two values of time, okay, the signals have the same value. Okay, for example, this one, no, itong periodic square wave natin, no, from -2 to 0, from -2 to 0, okay, ang value natin is 1, okay, but uh, at a certain time in which from 2 to 4, naulit na naman yung value natin na 1, okay? So, that's why tinawag siyang periodic, no? Up to infinity na yun siya, okay? Mauulit at mauulit yung value ng period natin, value ng signal natin dito, okay? So, yun yung ibig sabihin ng periodic function. So, try this example number 4, okay? So, it has a value of 2 pi, okay? It has a value of 2 pi. So, example number 5 tayo, no? We have here the discrete time signal or x of n is equals to 1. So, this is also a periodic function, the but the difference between the continuous one at saka itong discrete one is, okay, is yung discrete time signals natin, okay, repeated siya for the same value of uh x. Oh, okay? So, the same repeated pa rin siya. Same for our continuous one. But in here, define lang siya for a certain value of time for this. For example, this one here, no? Itong from 1 to 2, okay? Repeated siya, pero dyan lang siya define sa 1 at saka 2. Okay? So, yun lang. So, repeated. Okay? So, the same pa rin doon. Periodic pa rin siya, which is kasi repeated, pero define siya for a certain value of time. Okay? So, yun. Okay, so dito tayo sa exponential signal kasi most probably we are actually applying these signals, no, different kinds of signal on our feedback system. Okay, so dito tayo sa um, exponential signal. Exponential signals is those signals in which um, it has these kinds of graph, no, from lower values pumupunta siya sa higher values, or from higher values pumupunta siya sa lower values at some curve, no, some functions of curve. Okay, pa-curve yan siya. Okay, so probably its mathematical expression is e to the power of t, no, or um exponential to the power of time. Okay, so yun. Okay, so from this equation here. Okay, so yan. Okay, so this is are just the representation of exponential signals from exponential form into rectangular form. So, pakibasa na lang to. Now, when you say rectangular form, we have to convert this exponential form into value or into representation in which it has a real number and it also has an imaginary numbers. Okay? So, yun. So, yun. We have here a different classification or different graphs of our exponential function. Okay? So, pwedeng dumped siya for some value of time. Okay? And then, magiging undamped na naman siya for some value of time. Okay? So, based on this graph here. Okay? So, basahin na lang natin siya. So, finite energy and finite power signal. Okay, so this would be the power, no, since we are talking about most probably for a system as a power, no, we have to apply the exponential, okay, signals for our powers na for our okay, so we have to apply the signals that we are talking about previously for this power. Okay? Since our power is also as a function of time, no? So ibig sabihin nag-iiba yung power natin as times goes by, no? So ibig sabihin nun, kukunin natin yung properties ng power based on that simplification, no? As we can see here dito sa graph natin. Okay? I mean dito sa derivation natin. Okay, ito. So, basahin na lang natin to siya. Okay? So, yun. So, example dito sa example number 6. We have x of t is equals to 4 has an infinite energy but average power of 16. No, kasi from our formula for average power, no, we have to limit the integral of negative t to t 4 squared of dt as t is goes to infinity. No, so we have here 16. Okay, so therefore we have here the average power of periodic signals can be calculated on one period only. Okay? So yun. Same for example number 7. So basahin na lang natin siya. Okay, so dito tayo sa impulse and step function, or we have here continuous time impulse and step function. Okay, this function, okay, or these signals are signals in which it is only defined for time that is greater than zero. So ibig sabihin nun, hindi siya defined for time that is not greater than or less than to zero. Okay? So yun. So from this graph kung makikita natin, from time zero o from time na negative values, zero yung u of t natin. Then after ng zero natin, no? So nagkaroon na siya ng value na 1. So yun yung tinatawag na step function. Okay? Or impulse. Okay? So yun. So same with this one, sampling properties of impulse function. uh, Minsan kasi, no, one of the application of this impulse, no, kasi as a system, no, as a system na kailangan nating kunin yung properties, okay, or yung efficiency niya, we have to define that function at time t is equals to zero, no, or we have uh, s- to give some signal, okay, as an input signal of that system at time t is equals to zero. Okay, so yun. So that's why in here, pinag-aralan natin dito yung impulse. Kumbaga, nagbigay tayo ng malaking or nagbigay tayo ng certain amount of energy or signals doon sa system natin at time t is equals to zero. Okay, so yun. So, yun ibig sabihin ng impulse. Okay, so I hope these lectures gives you an insight about the different classification of signals, no. If you have any question about these topics, just ask it to me, no. Inshallah, next meeting we will continue our discussion for these topics. Okay, so that's all. Assalamu alaikum warahmatullahi ta'ala wabarakatuh.